Hi guys, this video is going to be looking at circles and the angle and arc relationships. We're going to focus on 4 different types of angles today, and these are formulas that you do have to have memorized for your test or your assessment. They are not given to you on any reference sheets. So here we go with the first one. A central angle is equal to its arc. Central angles are located at the center of the circle. Makes sense, right? Central, center. So if you take a look at this picture on the right hand side, we have angle ACB is labeled as 50 degrees. Then if you look at the arc that the sides of the angle open up to, arc AB is also labeled as 50. Central angles are equal to their arc. The next one we have is an inscribed angle, otherwise referred to as an on angle. An inscribed angle is equal to its arc over 2. They are located on the edge of the circle. I know circles don't really have edges, but hear me out here. An inscribed angle is on the edge of a circle, and it's half of its arc. So if the arc is 2x, to go inside to find the angle, we divide by 2. If the angle is labeled and we're trying to find the arc, we multiply by 2. Again, if you go in, you divide. If you go out, you multiply. We also can see an inscribed angle such as the ones over in the picture on the right. It looks a little bit different because you don't see 2 chords as you see in the first picture. You see a chord and something called a tangent. A tangent crosses your circle 1 time. A chord connects 2 points on your circle. This is still an inscribed angle because the angle's vertex is on the edge of the circle. Angle 1 opens up to arc BA. So if we knew that this arc was, say, 80 degrees, to find the angle, we divide by 2. If they told us that this angle here, angle 2, was 140 degrees, to go outwards and find the arc, we would multiply by 2. That's supposed to be multiplied by 2. So again, it's still an inscribed angle even though it looks a little bit different. Another type of inscribed angle that we have could be inscribed in a semicircle. A semicircle is equal to 180. So here's an arc of 180 degrees. It's a half of a circle. By the way, a full circle equals 360. So here we go with an inscribed angle on the edge of the circle, and my arc is opened up as 180 degrees, so to go inside we divide by 2. That gives us a right angle. 180 divided by 2 is 90 degrees. Another type of angle that we have is called an inside angle because it's located on the inside of a circle. Our formula, again, something you have to memorize, is inside angle over 1 equals big arc plus small arc over 2. So if you take a look at angle 1 here, it's an inside angle. It's not central because there's no center point that it's located at. And we have angle 1 opening up to arc DC. This will be our big arc. It looks bigger. Then, if you look at the back side of angle 1, it opens up to arc AB. So this would be our small arc. Inside angles are made of chords that intersect inside the circle. We also have something called an outside angle. Outside angles are equal to big arc minus small arc over 2. Outside angles are made of tangents or secants that intersect outside the circle. A tangent crosses your circle 1 time. A secant crosses your circle 2 times. So if you take a look at the pictures here, we have 3 different examples where we have secants and tangents all making an exterior or an outside angle. So angle 1, 2, and 3 would all be considered outside angles. And then they intersect a big arc and a small arc. Remember that we subtract these arcs this time, and the reason is because it's outside the circle. A trick for this is that we have chords for an inside angle that cross. they make a plus sign. Outside the circle, they don't cross, they don't make a plus sign. If you turn your page, we're going to take a look at some basic examples, and then we'll take a look at some Common Core type questions that you could come across in June. Okay, so for the first basic angle question, we have circle B. They give us a couple angles or arcs, and we're going to find the measure of arc FE. So let's choose to call this X. And you need to go through your list of options as far as identifying the type of angle that we have. Remember, our list includes something called a central angle. We have inscribed angles, inside angles. Oops, I just spelled inside wrong. Or we have outside angles. So go through the list. If you have an angle located at the center of your circle, it's called a central angle. And in this case, that's what we have. Once you determine what type of angle you have, write down the formula with it. Central angle is always equal to its arc. So if we have this arc CD with 55 degrees, then that means the central angle is 55 degrees. If we have an angle here, B or DBE of 58 degrees, then this arc that it opens up to is 58 degrees. You'll notice here that we have a straight line, which means that this is a semicircle because the straight line passes through the center. That's called the diameter. A semicircle, remember, sums to 180. So we can write ourselves an equation to solve for x. We have 55 plus 58 plus x equals 180. Go ahead and start solving. So I found the measure of arc FE to be 67 degrees. If we take a look at the next example, we have some angles and arcs again given to us, and it says determine the measure of arc SQ. So we'll choose to call that X. But in order to get arc SQ, it seems as though I might need arc QR. And arc QR is the arc that's opened up to from angle S. Angle S, we have to figure out what type of angle it is. Go through your options. Is it central? Is it located at the center? Nope. Is it inscribed? Is it located on the edge? Yep. So to go outwards and find its arc, remember that we multiply by 2. So we're going to take 95 and multiply it by 2. You may want to jot yourself a note that this was an inscribed angle, so when you look back at it, you know why we multiplied by 2. And so we have 95 times 2 gives us 190. Now our goal is to find arc SQ. So far we have arc SR is 75, arc RQ is 190, and now we need SQ. Those arcs, the red, the blue, and the purple, all together sum to 360 because it's all the way around a circle. So now we have X plus 75 plus 190 equals 360. So solving that equation, we should find that the measure of arc SQ is equal to 95. Moving on. The next one we have, it says determine the measure of angle EGF. So we'll choose to call that X. We're going to go through our options, our list. First option, remember, was central. Is it located at the center? Hopefully you're saying no. The next option is inscribed. Is it located on the edge? No. Third option is inside. Is it located inside the circle? Yes. So jot down the formula along with its name. Inside angle over 1 equals something over 2. Remember that these chords inside in the middle are making a plus sign for us, so we definitely have a plus between our big arc and our small arc. So we have to plug in the appropriate spots. Our angle is represented by x, so we have x over 1 equals, find your big arc, the 169, add it to your small arc, the 51, and put it over 2. From here you can add those two numbers on the top and then divide it by 2, just as the equation tells us. So we have x equals 220 over 2, so then x is 110. The next picture looks pretty similar, except that this time they give us an angle over here of 102. Something I forgot to mention in the previous example is that you want to make sure when you're doing inside angles that they all line up in a straight shot. So if I try to line up in a straight shot here with the 95 and the y, those two arcs, I notice that I'm not encompassing the 102. What I really need is an angle right here or right here. And I can see that they're on a straight line. Angles on a line, remember, sum to 180. So we have, say, x and 102 equal 180. So now we have x equals 78. So I'm going to replace the x with a 78. Now I'm taking a look at this and I see that the 78 is an inside angle. It's on the inside of our circle. So we have inside angle over 1 equals, try to fill in the right hand side of this equation. Then check back in with me in the next 30 seconds. Once you have the same exact equation as me, start plugging in so that you can solve for y. Make sure to plug into the appropriate spots. If you have an angle, put that in the angle spot. If you have an arc, put it in an arc spot. When I plugged in, I have 78 representing the angle over 1 equals 95 plus y over 2. And from here, we're going to cross multiply to solve. Go ahead and do so. If you need more time, just pause the video. Otherwise, we're moving forward because we got y equals 61. In this next picture, we have an angle that seems as though it's outside the circle. So this clearly indicates that it's an outside angle. And there is a formula for it. It's over 1 is equal to big arc, something related to the small arc, over 2. Now remember, our trick for the plus sign is when our chords cross each other and make a plus. That is not happening here with this set of secants, so this means that we're subtracting. Plug stuff into the appropriate spot. Find your angle. Is it the A, the 44, or the 30? Hopefully you said 30, that is the angle. Equals the big arc. Which one looks bigger, the A or the 44? Take away the small arc and put it over 2. From here, I'll let you solve and cross multiply. Pause the video while you're doing that. Check back in with me to see your final answer. So I found A to be 104 degrees. Take a look at number 6 here. It says determine the values of A and B. Notice that they give you an arc that's labeled as 224 degrees, and then B is the remainder of that circle. So we can first find B by taking 224 away from 360. Remember, angles or arcs all the way around a circle sum to 360. So we get B equals 136. So if B is 136 degrees and we're trying to find angle A is on the edge of the circle. As weird as it looks, it's on the edge, and so that means it's an inscribed angle, which is equal to its arc over 2. And the arc happens to be B, which we said was 136 over 2, giving us a value for A of 68. One more basic question before we move into those Common Core questions. It says that triangle ART is inscribed in circle O, with the measure of arc AR to be 74 degrees. Find the measure of A, R, and T. So if I take a look at this arc of 74 degrees and I follow the sidelines back to an angle, that gives me angle T. And if I want to go inside to find angle T, where T is located on the edge, we need to take 74 and divide it by 2. Remember, if you go inside, you divide by 2. Measure of angle T equals 74 over 2. 74 cut in half gives us a value of 37. Measure of angle T equals 37. If I take a look at this circle, I'm just going to kind of erase a little bit of what I've outlined here. I know now that angle T is 37 degrees, and I still have this arc AR 74 degrees. I notice that AT is a diameter, which means that this arc over here is 180 degrees. And if I follow again the sidelines back from that arc, that gives me angle R. If angle R is on the edge of the circle and inscribed in a semicircle, you should automatically know that angle R is a certain value. However, if you don't, take your 180, divide it by 2, and then you'll come up with that value. 180 divided by 2 gives you an angle that's 90 degrees. Woohoo! So now we have 90 degrees and 37 degrees in this beautiful, wonderful little triangle called art. And in this triangle called art, we now need to find the measure of angle A. And if you recall back from Unit 2, angles in a triangle sum to 360, holy cow, they sum to 180. So we have 90 plus 37 plus, say, A equals 180. Take a minute to solve that for yourself. You should have found that angle A is 53 degrees. Now we're going to start taking a look at some Common Core questions where we use the information that we just learned and just practiced in our notes to continue with notes at a little bit of a higher level. It says in the diagram below of circle O with diameter BC and radius OA, chord DC is parallel to chord BA. So find those segments, BA and DC, and mark them parallel. If the measure of angle BCD is 30 degrees, determine and state the measure of angle AOB, right here. So we'll call that X. Now, if you recall from Unit 2, parallel lines form congruent alternate interior angles. Notice that Z shape I just made? If this angle here is 30, then that means this angle up here is also 30. So angle ABC is also 30 degrees. Now something you have to recognize here is that this triangle OBA is made out of two radii, OB and OA, and then also a chord, of course. So if you have radii in a circle, all radii in the same circle are congruent. So we now have this beautiful isosceles triangle with an X in the vertex angle and a 30 in, say, the right-hand angle. Isosceles triangles, remember, have two congruent sides, so they also have two congruent angles. Now we have x plus 30 equals 180. X plus 60 equals 180. So x, our angle, is 120 degrees. Now that's one way to solve this. Another way to solve this would be to use more with the angle properties and arcs that we just learned about. So I'm going to erase what I just did. I'm still going to mark up the fact that we have parallel lines. If you're comfortable with the version the way that I just solved it, then move forward. Fast forward in the video a couple minutes to the next page, number 9. But if you're not comfortable with what I just did, then stick around, see if maybe this option will be more comfortable for you. So we still have a 30-degree angle here, and we know, again, still that parallel lines form congruent alternate interior angles. So that's a known fact that we have to use here. And angle B opens up to arc AC. And if I were to go outwards to find arc AC, I would multiply by 2 because it's an inscribed angle. So arc AC is 60 degrees. I'm just going to erase some of the outlining that I've just done. Oops, not highlighted, but erase it if I can now. Nope, just kidding. Okay, not going to happen. So we know that this arc here is 60 degrees. But again, we have a diameter. They told us that, which means that this big arc BAC is 180 degrees. So if I have 180 and I take away 60 of it, we're left with 120 degrees for arc AB. I know this picture is getting messy. I'm going to try and make it as nice for you to see as possible. So arc AB is 120, and if I were to look at angle AOB, the one I'm trying to find, that's located at the center. Central angles are equal to their arcs. So if the arc is 120, then that means measure of angle AOB is also 120. So again, this is just an alternate way to solve for this question based on what we just learned up above instead of having to recall so much from previous units. Go ahead and flip it once you're good. The next one is a reading question. There's no math that has to be done here. We just have to simply read, look at the picture, and choose an answer. These questions are actually pretty rare in a Common Core test because most of the time they make you do quite a bit of work for multiple choice questions. So here they say in the diagram below, segment DC, AC, DOB, CB, and AB are chords. So they're just pointing out that you have a bunch of lines going from one point to another within your circle. Okay, don't be scared by all of those crazy names. Then it says that FDE, the line, is tangent at point D, and radius AO is drawn. Sam decides to apply this theorem to the diagram. An angle inscribed in a semicircle is a right angle. Which angle is Sam referring to? So we need to look for inscribed angles. That means that we can eliminate like this angle here, AOB. That's a central angle. So actually choice 1's gone, out of the way. I'm looking for, again, inscribed angles. So that means that I could be looking here at angle DCB. We could look here at angle CDB. Here or here. Remember, inscribed angles are on the edge of your circle. Now, I marked all of these congruent to one another, but they're not. I'm just showing you that we can look at those inscribed angles. So if we take a look at the ones that are possibly in a semicircle, first I'm going to highlight my diameter, because a semicircle is made with a diameter. From there, I'm going to try to find an angle that uses point D and point B as its ends for the sides of the angle. Let me say that again. We're going to use point D and point B and follow the lines that come off of them to hopefully see them connect at one single point. So if I start down here at point B, I can either go towards C or I can go towards A. If I go towards A and then I follow the other line back towards D, it does not hit D, so this angle is out of the question. However, if I take and look at B going towards C, that's here, and then C follow it towards D, that's here. This, ladies and gentlemen, is an inscribed angle in a semicircle. So we're looking for angle DCB, which is choice 3. Number 20 or 29. Oh my goodness, what am I thinking? We've got number 10 here. It says in the diagram below, quadrilateral ABCD is inscribed in circle P. What is the measure of angle ADC? Let's choose to call this X. So find it. We've got an X here. If we think about the type of angle that ADC is, we know that it's on the edge of the circle. Angles on the edge of the circle, remember, are called inscribed angles, which is equal to its arc over 2. We're going to come back to that in a second. But think about the arc that angle ADC opens up to. Angle ADC opens up to arc ABC. So if we can find arc ABC, we know that we can go inside by dividing by 2. Now arc ABC is the opposite of arc ADC. Let me have you think about that for a second. ABC over here, say in orange, meets up with ADC here in red, and together they make a total of 360. So maybe if we can find the red arc, then we'll be able to find the orange arc, and then we'll be able to divide by 2 to find our angle X. So if I take a look at the red arc and follow its sides back into the circle, this helps me follow into angle B. Do you see that here? We have angle B opens up to arc ADC here in red. So if I know the angle B is 72 degrees, to go outwards to its big arc, we multiply by 2. To go inside, you divide. To go outside, you multiply. So we have 72 times 2, giving us an arc length, or an arc measure rather, of 144 degrees. Remember that we said the orange and the red together make 360. So we have 144 plus, say, I don't know, y equals 360. So first step was multiply by 2, second step subtract from 360. So in your calculators you are subtracting, and we get 216. So that orange arc is now 216, orange or blue, whichever one you're looking at, they're both denoting the same one. So now third step is to divide by 2. Remember, once we have this 216, to go inside, we divide by 2. Giving us a total value of 108. So our X is 108 degrees, choice 3. And our last question together is another reading question. You do have to apply some properties here. It says in circle O, shown below, diameter AC is perpendicular to CD. So AC is perpendicular to CD at point C. Chords AB, BC, AE, and CE are drawn. Which statement is not always true? So they tell us that angle ACB, I'm just going to start kind of coloring these in on my paper. You don't have to color them on yours. It's going to get messy unless you have a pencil that erases. Otherwise, just follow along with me. It says, so the first choice says angle ACB. Let's find that angle ACB is supposed to be congruent to angle BCD. So the only reason or only time that this would happen is if this segment BC was an angle bisector, or if these chords, or if these arcs out here rather, AB and BC, were congruent, then these inscribed angles would also be congruent. So I'm thinking that this might be our choice as the not always true, but let's go through the other options so that we can confirm that that in fact is not always true. Choice 2 says angle ABC is supposed to be congruent to angle ACD. So recall that we said that angle ACD right here is a right angle because it does say that it's perpendicular to CD. Also recall that we talked earlier about inscribed angles such as angle B in a semicircle. Because this arc out here would be 180 degrees, arc AEC, as a result of the diameter, going inside gives us a 90-degree angle. So if we have two 90-degree angles, of course they're congruent to each other. So choice 2 is definitely gone as our not true choice. Taking a look at angle BAC and DCB next. BAC right here, and DCB right here. Now you might say, holy cow, I don't know about that, that's like a real crooked Z. But take a second to actually look at the arcs that they open up to. Angle BCD there, the one in blue, opens up to arc BC. And if I were to extend my lines for my red angle, BAC, it also opens up to the orange arc, BC. If inscribed angles open to the same exact arc, then they're congruent to one another. And I'll give you an example of this. Say that the arc is 40 degrees. To find inscribed angle here in blue, BCD, we divide by 2. To find inscribed angle here in red, BAC, we also divide by 2. Taking 40 and dividing it by 2, no matter how many times you divide 40 by 2, every time you get 20. So inscribed angles that intercept the same arc are congruent, meaning that choice 3 is now gone, not an option anymore. So then we're going to take a look at angle CBA and AEC. Angle CBA, that's our right angle again that we just talked about, and angle AEC. Now if you take a look at angle AEC, this again is a right angle inscribed in a semicircle. Here's our diameter, here's our semicircle of 180 degrees. Going inside, we divide by 2, giving us 90 again. So that blue angle and the purple angle are both right angles, meaning that they're congruent. So choice 1 is the not always true choice here. After this, you're moving on to practice. I know it was kind of a long video, so thanks for toughing it out. Take a look at the practice before you move on to the assessment. Remember, if you have questions, feel free to ask any teachers that are around you. Otherwise, go back, review, revisit the video. I think I did a pretty thorough job of explaining it, but if you need more help, don't be afraid to ask. Good luck!